Section 8.4, vectors and dot product. Let's check what's the meaning of dot product. So if we have two vectors, u and v, remember this is the component form of the vector u. Here is the component form, the first component, the second component. And here is the vector v, here is the first component and the second component. The dot product between these two vectors, and there is many applications for this one. We're just going to study how it's going to be the dot product, how we're going to find the angle. The dot product between u and v is going to be u1 times v1 plus u2 times v2. Okay, is that hard? That's the dot product. Properties of dot product. If you do the dot product between u and v, it's going to be the same result if you do the dot product between v and u. Dot product between v and vector with the zero is going to be 0. Dot product with sum or addition is going to be u dot product with v and u dot product with u with w. This is important. If you remember before, to find the length of any vector is going to be the first component square plus the second component square. Yes or no? We need to find the length. That means now, if I need to find the length, I can just say, okay, the dot product equal the length square. So if I said, okay, the length square is going to be, if you take in the square for this side, and instead of doing this one, you're going to say, okay, it's the same thing, the dot product. So now this is an easier way to find the length. I'm going to say, okay, if I do the dot product between the vector and itself, is going to be the length square. Then I take the square root for this side, is going to be the length. So you have another rule to find the length. We can do that when we find the angle. A scalar times the dot product is going to be, you can multiply the scalar with the first vector or the scalar with the second vector. These just the properties. You can check these by checking vectors and you can apply the properties. Next part, find the angle between two vectors. If theta is the angle between two vectors, here is the vector u and here is the vector v. If we need to find the angle, you can say, okay, cosine theta is going to be the dot product over the length of u and the length of v. Okay, then it's going to be cosine theta equal this side. Next part, what are you going to do? You can say theta is going to be cosine inverse to the dot product between u and v and the length of u, the length of v. You can use this formula else to find right away the theta, or you can say, okay, cosine theta equal here. And then you're going to take the inverse, cosine inverse, the theta is going to be cosine inverse. By using this formula, that means if you multiply the cross product here, is going to be the dot product equal the length of u, the length of v cosine theta. This is look like another formula to find the dot product. So it's not hard. You see the examples here on the board. We can start from using this example before we go into the orthogonal vectors. These examples, find the dot product between u and v. And you can see we have u and we have v. How are we going to do the dot product? U dot product with v is going to be u1 v1 and u2 v2. Is that right? Yes or no? Be careful here. Okay. When you do the dot product, there is no the component form because the result is going to be a number. When you do the dot product, the result is going to be just one number, not a vector. So you can say U1 times V1 plus U2 times V2. The result when you add is going to be just a scalar, a number, okay? So not a vector. So be careful from this one. Let's check these examples. That's mean the dot product is going to be U1 V1 plus U2 V2. And it's going to be U1 times V1. That means 7 times -5 plus U2, which is 2 times V2, 3. That's going to be -35 plus 6. And how much going to be negative? See the result? So the result for the dot product is going to be just a number. We do the same thing here. Find the dot product between U and V. So it's going to be U dot product with V is going to be U1 V1 plus U2 V2. U1 -20 times V1 is 1 plus U2 is 4 times V2 is 5. -20 times 1 is going to be -20 plus 4 times 5 is 20. So the result is going to be 0. Is that hard? So you see, we're just using the rule. U and V, use the dot product, U dot product with V. Here's the rule. Multiply, multiply, and add. Same thing here. Multiply, multiply, and then you're gonna add. The result always is going to be a number, okay? The result for dot product between two vectors is going to be a number. Can we do the same thing here? Two vectors, I need to find U dot product with V. So U1 V1 plus U2 V2. U1 is -2 times V1 is -1. And be careful from the sign. You see what I'm doing? -2, -1. Plus U2 is 7. V2 is -9. That means it's going to be +2 plus -63. So the result is going to be -61. Dot product between U and V. So U dot product with V is going to be U1 V1 plus U2 V2. U1 is 0 times V1 is -4 plus U2 times V2 is 0. That means it's going to be 0 plus 0. The result equal. So let's check next example. Find the angle. So I have the formula. It says cosine theta equal dot product between U and V, the length of U and the length of V. Don't think so. This is going to be it. Erase this one. Okay. Now let's check this one. The vector U and the vector V. So what's the first step? My formula it says what? Cosine theta equal U dot product with V, the length of U and the length of V. Yes or no? That's the formula. Now I need a dot product I need length u and need length v. So let's check here. Can I write down this u as a component form? Remember that. U equal what? Write down as a component form. Can you? 6 and 3. 6, 8. And the vector v is going to be. Do you see the I component?
0.
That means 0. So there's no I component is 0. I see the G component, that means -2. So be careful. You can't see the I, that means the I is 0. The first component is 0. You can't see the J, that means the second component is 0. So now I have U and V. So I'm going to find the dot product. U dot product with V is going to be U1 V1 plus U2 V2. U1 6 times 0 and V1 is 0 plus U2 is 8 times V2 is -2. This is 0. 8 times -2, -16. So the result is going to be -16. So I have the dot product, which is here. Now, next step, we're going to find what? The length of U. If you want to use the formula over there, or you want to use the old formula, it's up to you. The length of U, you're going to say, okay, I'm going to use this one, which is equal the first component square, U1 square plus U2 square. That means the length of U is going to be 6 squared plus 8 squared. Is going to be 36 plus 64. Going to be square root of 100, which is equal 10. Yes or no? Check here. Remember over there they said, I told you you can do the dot product equal the length square. Okay? Yes or no? That means if I do the dot product, it's going to be exactly the same thing, the length square. What's the next step? I have the length of U, I'm gonna find the length of V. The length of V is towards here. The length of V is going to be square root of V1 squared plus V2 squared. That means the length of V is going to be 0 squared plus -2 squared. The length of V is going to be square root of 0 plus 4, and it's going to be equal 2. Because 0 plus 4 is going to be 4, the square root of 4 is going to be 2. So we have the length of cosine theta equal the product between U and V, the length of U, the length of V. That means cosine theta is going to be equal. The dot product is -16. -16. The length of U 10. The length of V is 2. So 10 times 2. That means it's going to be equal -16 over 20. So cosine theta is -16 over 20. Can you simplify it? By 4. That means cosine theta divide both by 4. So it's going to be -4 over 5. Can we find the theta? Theta equal what? Theta equal what? Theta equal what? Cosine. So cosine inverse to the negative 4/5. Tell me how much is going to be theta. So we got the angle equal 2.50. Again, when you need to find the length, you can use this rule, okay? Or you can say, okay, if I do the dot product between the vector and itself, we have to get exactly the same length. So I'm gonna do with the u. They're telling you dot product with u equal the length of u squared. So if I do the dot product between u and itself, that's mean it's going to be 6 times 6 plus 8 times 8, which is equal 36 plus 64, which is equal 100. 100 equal the length of u squared. What about the length of u? You have to take the square root for 100, which is going to be 10, you guys? So both ways going to be right. If you need to find the length, instead of using the root, you can say, okay, I can use the dot product. Okay, so both is going to be right. The same thing for the v. So they ask you to find the angle. Find the angle theta. Because this is number one, here's the second example. So when they ask you find the angle, go ahead, write down the formula, which is the rule says cosine theta equal dot product over the length of u, the length of v. So I can know what I need to find. What I need to find the dot product. So u dot product with v, u1 v1 plus u2 v2. u1 3 times 0 plus u2 0 times -7. So how much the dot product? 0 plus 0 and equal 0. What does that mean? Do I need to find the length of u and the length of v? You want to find the length of u and length of v? Yes or no? Do I need to find the length of u and the length of v? Why?
It's 0.
Because the dot product is 0. That's mean if I plug in cosine theta equal dot product is 0. Length of u, length of v are numbers. 0 divided by numbers is going to be 0. That's mean it's going to be only cosine theta equal 0. So how much is going to be theta? Cosine inverse to the 0. The result is going to be theta equal 1.57. And if you want to find the length of u, you can say, okay, the length of u squared is equal, I'm going to use the dot product. U times u. So u times u, that's mean 3 times 3 plus 0 times 0. So it's going to be 9. That means the length of u squared is going to be 9. The length of u, take the square for both sides, is going to be 3. I just need to practice by finding the length by using the dot product. Instead of using the square root, I'm going to use the dot product. The same thing, the length of v squared is going to be v times v. Here's the v, that means 0 times 0 plus -7 times -7. So it's going to be 49. The length of V squared is going to be 49. The length of V, take the square of both sides, is going to be 7. So when you plug in here, 3 times 7, the length of U, the length of V is going to be the same thing. It's still cosine theta equals 0 divided by 21 is going to be 0. Okay? So the main thing here, when I did this extra step to show you, you can find the length by using the dot product, or you can find the length by using the square root of V1 squared plus V2 squared. Both is going to be right. You can use this formula or you can use the dot product. Orthogonal vectors. Two vectors, U and V, are orthogonal. You're not going to see perpendicular anymore. You're going to see the word orthogonal. With the vectors, you can see orthogonal. That means perpendicular. That means check here. Two vectors are orthogonal if and only if the dot product equal what? 0. That means if you have two vectors and they can tell you, prove that these two vectors are orthogonal, you're just going to go ahead and do the dot product. If the result of the dot product equals 0, that means these two vectors are orthogonal, which is mean perpendicular. That means the theta equal what? The theta equal what? 9, okay? We're gonna go ahead to the next part. Projection. So, not this one. So this is U over V. Projection. So we have two types of projection, not two types, but it depends about which vector you're gonna project to the other vector. So if you want to do the projection of U onto V, I need to project, here's the vector U, project this vector to the vector V. I'm gonna project the vector U onto V. You see what I'm doing? Here's the vector U, project onto the vector V. So if I want to do projection between U onto V, here's the rule. Project U onto V is going to be the dot product between U and V over the length of V. And everything times the vector V. The opposite one is look like, I'm going to do the same graph, but here's V and here's U. Now the next one, we're going to do projection of V onto U. V onto U, okay? So check the difference. The projection of V onto U is going to be the dot product between V and U over the length of U times the vector U. So you have to look to what they're going to tell you. Do projection of U onto V or V onto U, because there's difference with using the rule, okay? You got it? Do exactly the same steps. Every time when they ask you find or prove that, determine whenever U and V are orthogonal. You want to do the dot product. If the dot product equals 0, that means they are orthogonal. If not, that means they are not orthogonal. So we're just gonna do the dot product. So we're gonna say, okay, it's U dot product with V equal U1 V1 plus U2 V2. That means U1 times V1 -7 plus U2 times V2 is 5. Now tell me, is that equal 0? This is -21. That's what? That's what? Okay. 75. Is that equal 0? So it's not equal 0, equal what? How much? Okay, 5, 4. So it's not equal 0, that's mean not orthogonal. That's it. You use the product. Can I do the same thing with the next one? Tell me, is that orthogonal going to be? So to find it's orthogonal or no, I'm gonna do the dot product. So U and V, so that's mean U1 V1 plus U2 V2. U1 is 32. V1 is half. Plus U2 is 12. V2 is -4/3. Simplify this one, half the 30 is 16. It's going to be 4. 4 times -4 is -16 equals 0. That's it. We're gonna do the dot product to find if it's orthogonal or no. What's the theta for the second one?
90.
90. You already typed it over there, right? So when it's orthogonal, that's in perpendicular, the theta equal 9. So find the projection of U onto V, and again, be careful. So write down the formula. Well, it says the projection of U onto V is going to be the dot product between U and V over the length of V, yes or no? Times V. Yes or no? Now, what the first thing we need to find the length of V, the dot product, and this is still a vector. So the whole thing here between the parentheses is going to be a number times the vector. Okay, so go ahead, find the first thing, the dot product. U dot product between V is going to be U1 V1 plus U2 V2. Tell me how much it's going to be. And then you're gonna find the length of V. So U1 times V1, that's mean 4 times 7. U2 times V2 plus 4 times 1. That's mean 28 plus 4, and it's going to be 32. The length of V, you want to use the square root or you want to use the dot product? It's up to you. Let's use the square root of V1 square plus V2 square. So maybe square root of 4 square. Now this is the U. 7 square plus 1 square. So it's going to be the square root of 49 plus 1, 50. What's the square root of 50? What's the square root of 50?
5 square root 2.
5 square root of 2. You're going to say, okay, it's square root of 25 times 2. Yes or no? What's the square root of 25? It's 5, and keep the root, the 2 under the root. So we have the dot product, that means the projection of U onto V is going to be equal. The dot product is 32. The length is 5 square root of 2 times the vector V, which is 7, 1. What's the next step? Be careful. This is a vector. V is a vector. 7, 1. This is a number. So can I distribute the number on the vector? Yes or no? We checked a rule yesterday. It said CV equal CV1 V2 and it's equal CV1 CV2. Yes or no? You can distribute the scalar to the vector. So the same thing. This is a number. Don't confuse yourself. 32 over 5 square root of 2 times 7. We're just going to multiply the 7 by 32. How much is going to be? How much is going to be?
24.
224 over 5 square root of 2. And 32 times 1. 32 over 5 square root of 2 and a close. So that's it. So this is the projection of U onto V. We get this result. Okay, and be careful here. So this, everything here is just a number. Distribute the number to the vector. So the result for the projection is going to be a vector. The result of the dot product is going to be what? A number. So like for this example, we define the projection. The projection of U onto V is going to be the dot product. U dot product with V over the length of V. Here is V. So I'm going to start finding the dot product. That's mean U dot product with V, U1 V1 plus U2 V2. U1 8 times 8 plus 4 times -6. So it's going to be 24 minus 24 is equal to the 0. So the dot product equals 0. That's mean dot product equals 0 divided by any number times the vector V. The vector V is 8 -6. Any number divided by 0 by any number. 0 divided by any number is going to be 0. Dot product with, and the vector is 8 -6. So you feel like you're distributing this number on the vector as a scalar. So it's going to be 0, 0.